Hi guys, I'm Bobsi, and in these couple of videos we're going to be looking at how you make sort of your own little cute roguelike game. A bit similar to something like Vampire Survivors, but with multiplayer. So you can see here we have damage, we have XP, we have this attack, which I right now just call Fireball. We have the state, of course, where you can die. So you can notice this player now goes down and he's downed. I'll have to stand close to him for 5 seconds in order to properly revive him. So let me try and see if I can get over there. You can see we have the upgrade screen now that we've leveled up. As you can see, we only have one attack, but it'll be really easy for you to add more attacks with this setup. There's some things that I've definitely done nice and scalable, and there's definitely some places where I've just taken shortcuts to make it work. So let me try and see if I can stand close to this guy for 5 seconds. There we go, and now you can see he's back up. And we're going to pick the last upgrade. We don't have more upgrades now. Cool. So this is essentially what we're going to be working towards. And as you can see, I've set it up in this sort of pre-test folder. So I'm going to be doing everything or redoing everything from scratch. But I'm of course going to be using this sort of a recipe by myself to explain to you guys properly and make sure I don't go backwards too much. So yeah, let's start by just working through and essentially making this game that we have right here. So first of all, let me make a new scene and let's just start completely from scratch. So this is going to be the tutorial scene. And opening that up, let's just set stuff up like a ground, for example. So I'm going to make a ground, I'm going to make it 100 by 100, and I'm going to give it a material for the ground, like so. So there goes, now we have a material for the ground. And let's set up all the network stuff. So of course, make sure you've already imported PurrNet and everything like that. And actually one thing I just very quickly want to shoot out there as well. This video right here, the only multiplayer tutorial you'll need, I beg of you, at least please watch the first sort of 12 minutes of it. It's extremely helpful. It's going to help you get a lot further with networking. And if you have the base understanding that you get in the first 12 minutes here, you'll be able to get a whole lot further with networking than you ever have before. I can assure you that. All right, cool. So getting further into it, let's set up the basic networking stuff. Again, I'm going to assume you're already familiar with setting up parallel sync. You're already familiar with PurrNet. If not, go and have a look at that video. That'll give you a good overview. And I also have a whole bunch of videos on the topics on my channel. Okay, so setting up the network manager, like so. And I just like always zeroing it. And I'm going to add the network manager here. I'm going to give it the unsafe rules. And I already have a network prefab set up. If you don't, you just click new, of course. All right, great. So now we have the network set up and everything should work. And if we just press start, you can see we've essentially started on the network now. Great. All right, so let's add a player spawner and let's get started on making our player. So I'm going to make a new object. I'm going to call this our player. I'm just going to add it to 0, 0. And let's also add the body. Now I've just imported some Kenny assets here from the graveyard pack. I only essentially took the zombies and the digger, it's called. And I'm just going to add that here, 0 it back. And there we go. And now we have our little character. And he's, luckily for us, very sort of easily rigged, so we can just very easily put the arms where we want them. Let's say we want them in front. I guess he's not a zombie, so I just put him down like so. So there we go. That's nice. Got him. All right, cool. So now we've got a little player set up. Now let's set up a capsule collider as well, just to make sure that he has a collider. And it's a radius 0.25, and I'm going to set it up by 0.5, and that looks pretty good. Then I'm going to add a rigid body. That's how I want him to be controlled. And I'm just going to give him a very high mass, just so he can walk through most things. And I'm going to freeze his rotation here. And I'm also going to freeze his Y position. Cool. Okay, so now we have these set up, and we essentially don't really need to look at these much again. We also can easily just set up the network transform, just to make sure that the position is easily networked as well. And now let's get into actually scripting. So let's make a new folder, call it player. And I'm going to make the player movement script here. All right, cool. So with our player movement script here, let's start by just making it into a network identity, as we always would with networking. And let's just set up the parameters that we need, like for example, the speed that he needs to be able to move at. And I also want to work with Cinemachine. If you're not familiar with Cinemachine, I would greatly urge you to give that a look. It's extremely useful in Unity, and so we're going to be using the Cinemachine camera. This is of course also something that you have to set up or import. You can just import it in. It's part of the Unity packages, the Cinemachine package. And let's also have a reference to our rigid body here. It's just going to call underscore rigid body. And then in awake, let's just do try get component out rigid body. There we go. So now we've gotten our rigid body. And if you want to really be sure, we can also do the require component type of rigid body, just to make sure it exists. All right, cool. So now we have all of this. Now let's get into the basic networking setup. So entering the onSpawned method, which calls back whenever this object is spawned. What we can first of all do is we can say enabled equals to its owner, which essentially means if we're not the owner, the object will get disabled, which means we can't really control it because we're going to be controlling it through the the Unity update loops, and this obviously wouldn't work if we don't use it. Nice. Okay, so moving on, let's onto the player camera as well. I'm going to do player camera dot priority dot value, because we're going to be working with the camera priorities, and we're essentially going to be setting this to, if we are the owner, we want to be setting it to 10. If we're not, we set it to 0. That way we only use the camera that we want to use. All right, cool. And another thing, because of the way that we want the camera to be following, we don't actually want it parented to our character. So what we can do is we can do, if we are the owner, we essentially just want to unparent the camera. So player camera dot transform dot set parent to null. That way we also unparent it. Cool, so let's just go and set up the player really quickly with the camera and make sure that this very base of the camera logic is working. So going in here, I'm gonna add the player camera. And I'm gonna add the Cinemachine camera to this. Here we go. And you can also just click add brain here. That'll add the Cinemachine brain to your main camera up here. You don't have to worry much more about that. Now positional control, I'd wanna set it to follow. And essentially I wanted to follow the tracking target of our own player. And that should mostly be it. Now if I go on to, oh, I see I added these to the wrong object. Lovely. Let me remove these again. These should be on the parent. So into the player here. Of course, I want to add the capsule collider. This is my mistake. 0.25, 0.5. Also the rigid body. And of course, constraint, and make him 30 thick. And the network transform as I was doing before. And let's also just add the player movement script here as well. Cool, and now we can drag and drop the Cinemachine brain here, give him, I don't know, let's say 5 speed. But I guess the speed doesn't really matter right now. And the next thing that we actually need to set up is where the camera is following from. I'm gonna go with something like -3 and 7 in height. That way we can also make the camera just look down. Well, let's have a look here to see how it looks. So something like that. And then we can just up the vertical field of view. Something like 60, I think works quite well. It can also maybe be 55, depending on how close we want to feel. I think 60 was nice. So let's go with something like that. Have the camera look, I don't know, yeah, around 65, I guess, down. And I think something like this, and then I don't want it offset. There we go. Oh, sorry, it did it itself, my bad. Okay, and so as we go into play now, you can see here as we move the player around, you can notice how the camera is following smoothly. Don't mind that it's yelling at us right now, we're not really doing much. I'm essentially just testing this. You can see as I move him around, the camera's following nicely. Cool, so that works. Now let's go and actually make our player prefab. So I'm just gonna drag and drop him in here. I'm gonna go into Network Manager and select to spawn him here. We can also make some spawn points if we wanted to. That might not be a bad idea. So let's make an environment sort of folder here. I'm gonna plop the ground in there. Oops. Environment, it's gonna be at 0, 0. I want the ground at 0, 0. I'm gonna drag and drop that in here. And now let's also make some spawn points. So let's do something like that. Let's make it the orangey tag here. And let's put one there, one here, one here. There we go. So now we have like a couple of spawn points. And we can just drag and drop those into the spawn points list here under the player spawner of PurrNet. Cool. So now that we have that, I'm going to hit play. And as you can see now, our player spawns. We obviously still can't move, but now he spawns. It doesn't yell at us. And as we move him around, the camera is following smoothly as we want. All right, great. So next thing is we need him to actually move. So let's go into fixed update as you would normally work with a rigid body. And let's first just generate our input. I'm just going to make a new vector 3. I'm going to do input.get axis raw. And I'm going to get the horizontal axis. Then we're going to do 0. And then we're going to get the vertical axis as it wants right here. Cool. And then we can just say if input.magnitude is greater than 1, then we just want to normalize the input as well. This just means that it's essentially too much. We don't want to be moving faster than the speed we're feeding. Now we can generate our movement, which we do by just doing input times speed. And then we can essentially set the rigid body.linear velocity to our new movement. And there we go. Now we should be able to move around nicely. So let's go and give that a quick test. So going in here, I play, and now I can move around. Now notice how, I don't know if you can really see it, but the player looks kind of jittery. This is easily just fixable by going on the rigid body, setting the interpolate to interpolate, like so, and now it should look nice and smooth. This is just because he wasn't moving at the same frequency as the camera, which, you know, can look bad. So now by interpolating, it's essentially smoothing every frame. All right, cool. Next. Also, let's also just quickly handle his rotation. For that, we just want to check that the rigid body dot linear velocity is not vector 3.0. The reason for that is because we want to set what's called the look rotation. So we want to do transform.rotation equals to quaternion dot look rotation. And we want to set that to the rigid body dot linear velocity. And you cannot set that to a vector 3.0. You can also do vector 3.up here. You never want to set a look rotation to vector 3.0. Unity will get very upset with you if you try and do that. And now essentially our player should be rotating in the direction that we're choosing to move him. Cool. And now let's just go test this in multiplayer as well. This should already just work. I mean, it's really easy working with something like this with PurrNet. So if I just hit start and I hit start, and as you can see now the other players here, he can move around, and yeah, now we're just scooting all over the place. I think maybe 5 is a little quick. Let me try and set it down to 3. I think this probably feels a little better. All right, cool. Now we have this set up. Now let's move on to the next stage. And I think one of the most fun things for us to work on early on is figuring out how we want to do the attacks. And this is going to be a little bit more of an interesting setup, right? So we're going to go to our, so let's try and go to our, let's make a new folder, just call it attacks. And I think this is essentially where we want to work with all the attack stuff, right? Before we enter the attacks folder, actually, let's do it in the attacks folder. We essentially want to create the base of all our attacks. So I'm gonna make a new script, call it attack, and we're gonna open that up. Whoops, opened it up wrong, put it there, there we go. Right, so now that we have our attack, we wanna set this up as a network behavior. This is gonna be the very base, so therefore we're gonna make it an abstract class. So this is gonna be the base of all our attacks. And essentially, we want this to take a few different things and be able to do a few different things. First of all, anything that inherits from it, we want to be able to initialize, right? So if I do a public void initialize, and this is going to be called from the outside, this is what's going to happen on initialization. And then we can also make sort of an internal initialization, a protected abstract void on initialize, which of course should not be extended like that, should just be like that. And we can also make a public abstract void tick. This is essentially going to tick whenever the attack is active. And this is a good level of control for us to be able to have. This design that we're working with right here, by the way, is called data-driven architecture. And it's essentially just a lot more scalable. Now, it's not that I'm going to make the absolute utmost scalable setup here, but it's going to be good enough for a roguelike game. Now, the next thing that we really want is we want attack data. So I'm going to make some attack data. This is essentially what our attacks are going to be referring to. So for example, this can be, we can start by just having all the things that every attack needs. First of all, let's give it an attack ID. The reason for an attack ID is just so we have some kind of unique identifier. You could just generate this if you wanted to. I'm just going to type them in because it's really not that difficult. We're not going to have hundreds and hundreds of attacks. If you are, I would definitely say generate it. You could generate it from the file path or whatever you want. There's plenty of ways to go about it. But for now, I'm just going to also have the attack name. You could also just use the attack name as the ID. There's nothing wrong with that. But let's say you had 2 attacks that for some reason were the same name, or you wanted to have some kind of illusion thing going. You know, they could be sharing, and then ID has to be unique. So this is just an added layer of safety. And then we might also want some kind of icon for it. So we can do sprite for the icon, and we can do a public attack. And this is going to be the prefab of the attack. And we're going to get into why this is in a little bit. And let's, actually, let's keep it at this. Let's keep it at this for now. So going back into our attack, now we want the attack to actually take in this data. So we want, or hold this data, so we want a public attack data, which is going to be our data. And we're going to have this be a public getter, but a private setter, just so nobody outside can manipulate this data, but they can see it. And we also want a public int for the level that we're currently in. Also, once again, we want to get it publicly, but we just want to set it locally, so nobody outside can mess with the level. This is really just for safety. And now in here, we can send in the attack data, and we can send in the level that we're supposed to be. And then we can just do this.data equals to data, and we can do this.level equals to level. And then we can run the onInitialize. All right, cool. So this is essentially the very base of our attack class. And this is a great start. Now let's try and figure out who's going to be using this attack. And for this, we probably want something we can put on the player, like some kind of attack handler. So let's go into the player script and let's make this. So I'm going to call this attack handler. You can call this exactly what you want, but this is essentially what's going to be responsible for actually calling the attacks, adding the attacks, you know, like doing the ticks on the attacks and stuff like this. So first of all, let's once again make this into a network behavior. And with this as network behavior, let's make a serialized field, private list of attack data. And this is going to be the attacks that we want to start with. So we can just call this like initial attacks or something. Just so right now we have something to also initialize and play around with before we add all the upgrades and stuff. Cool. So we're going to do our unspawned. And first of all, we're just going to say if we're not the owner, we just return. Next thing is we of course want to add all our initial attacks. So we loop through our attacks. And this is just going to call our attack. And we can just do something like add attack and feed it the attack. So, but now we've got to figure out what is add attack, right? So let's move on and let's do a public void add attack. And we already know now that this is going to be taking in our attack data. So we're just going to call that data. Yeah, so now we have this and we've got to figure out what exactly do we want to happen when we add an attack. Well, the way that I want them to work, because we've set up attacks as network behaviors. So my thought is we're actually going to sort of spawn the attacks under the player. So everybody can see that the attack exists. It exists on the network. And this is probably going to be the easiest way to do it. So an attack is sort of going to have its own object. And that object is going to be spawned under the player. Which is also why we set the attack data to have the prefab. This is where it comes in handy. So we're going to do, let's start by just doing of our attack and then instantiating the attack. So we're going to do the data.prefab and we just wanted to parent it to our, or child it, I guess, to our transform. And then we're going to do attack.initialize and we're going to initialize it with its own data and with level 0 because it's new. And then we can also keep a list over all our active attacks. I think this is probably generally just a good idea to have because we will need it in a little bit for example, ticking them. So we can have a string to attack. The reason for the string is, remember, we have an ID for the attacks. So I'm just going to call this active attacks and set that equals to new. So now we can also do active attacks at the data.the attack ID is equals to this attack. There we go. So now we've just set that up too. However, we might want to be able to level up the attack, right? And this is where the dictionary also comes in handy. So what we can check is if the active attacks dot contains key, if we already have the attack.attack ID, we might want to do something completely different. So in here, what we can then do instead is we could just easily calculate the new level and send the new level. So let's do that. So int new level equals 2, and we're going to get the active attack. And actually, instead, let's do try get value, just so we can get the attack out here of our attack. And then here we can just do, oops, instead of that, we just do attack. Oh, let's just call it, let's call it ATK, for example. Doesn't really matter. Let's call it ATK dot level +1. And so that's going to be our new level. And now we can just do attack dot initialize again. And we essentially just initialize it with the new level. So attack dot initialize, we're going to feed it the data and we're going to feed it the new level instead. So there we go. So now if the attack already exists, we'll essentially just level it up when we call this. And if it doesn't exist, we'll create it. All right, great. And also let's just for future purposes add a little helper method. So let's do a public int get level, which is going to be very easy, right? All we have to do is just we return the active attacks dot try get value with the ID that we feed out of our attack. And then we can just say if the attack exists, we'll send back the attack level. If it doesn't, we'll send back 0. If you're not familiar with this little question mark, it's very simple. It's essentially just a one-line if statement. So all we're essentially doing is we're saying, is this true? Meaning we've got the value. Then take the attack and feed the level. And if it is false, meaning we don't have the attack, we just send back 0 because there is no level. All right, great. And one of the last things is also we want to tick our attacks. Remember that? So we have this on tick here. And we essentially want the handler to do that. So when we have an attack, we want this to be responsible for it. And this is very easy. We can just inherit from iTick in PurrNet. And this will automatically give us the on tick callback. I just created it by holding Alt and Enter on the iTick here. Or you can just add it yourself after adding the iTick. And let's first of all just say if we're not the owner, we just want to return because only the owner should be handling the shooting in this case. We can also just for safety say if this is not enabled, return, and this might be relevant in the future, a little foreshadowing for you. And then we can just for each through all of our active attacks. And we can once again call this an attack. And then we can just do attack.value.tick. There we go. So now we're essentially ticking it on tick. And we're only doing it when it is active. So this is a really good level of control to have. Okay, cool. So now we have our attack handler, which means we have our attack, we have our attack handler now, and we also have the attack data. Now, one thing I completely forgot is the attack data should of course also be abstract, because every attack could have their own piece of data. This is really where the scalability of this kind of setup really comes into strength. So let's make this into a scriptable object. And so now attack data essentially just holds some information. Now, another thing I also think is very valid is that since our attacks will have levels, we might want different descriptions for different levels, right? You could also do the same thing for the name, but I'm just going to do it only for descriptions. So I'm just going to make a public list, like so, of type string. And this is going to be level descriptions equals to new. There goes. Now we have a bunch of descriptions as well. All right, cool. So now let's move on and let's try and actually make an attack now. So if we just quickly go back here on our player, let me just remove these. On our player, we can now add the attack handler like so. And right now you'll notice it doesn't really do much. It can take in the initial attacks, but we don't have any. Right, so let's go ahead and make some attacks. So first things first, in our attacks folder, let's now go ahead and make the fireball attack, which was the one I had before. So now that we've opened up the fireball attack, I can make this once again inherit from attack. Not once again, sorry, it should inherit from attack. I can remove what we already have here. Now I can do Alt Enter again, implement missing members, okay. And there we go. Now we have the oninitialize and we have the ontick in here. And this is essentially all that we have to do, right? So let's do something, for example, let's locally keep track of our data, for example. Or actually, more importantly, let's keep track of the last time that we shot right now, so last cast time. And then of course I also want to keep track of our data, which means we have to go and make that. So let's also go and make the data. So going back into the attacks, I'm going to create once again a new file, and this is going to be the fireball data. Like so. All right, cool. And in here, this is of course going to inherit from attack data. And what we want, first of all, let's make a system.serializable struct. So we can make a private struct or public struct. Sorry, let's make it public so it's accessible. Public struct. And this is just going to be our level data. And this level data right here is going to be specific to the fireball. So this can, for example, be things like how many projectiles we want, like projectile count. This can be public int damage. This can be public float cooldown. This can be public float speed, right? And you can have all sorts of things here. You can have as much data as you want. This is now data only relevant for the fireball data. So now next thing that we're going to do is we're going to make a serialized field, private list, and we're going to make a list of this level data. And this is essentially going to be our levels. And now we can also set this equal to new. Doesn't really matter much here. So let's do public level data. And this will be how we get the level data of a certain level. So we'll feed in the level that we want to get it from. And all we'll have to do is we'll do levels. Underscore levels dot. Oh, sorry. And then inside the levels here. Now here we want to clamp it to how many levels we actually have, because we obviously don't want to be able to get levels outside of what we do. So I want to do mathf.clamp. And this will essentially be clamping the level that we feed between 0 and however many levels that we have. Count -1. I want to be able to get outside of the array. Cool. So now we should always be able to get a level by just doing get level data, and it should automatically be clamped. So even if we should be trying to get to a higher level, it should be trying to do it. And actually, let's just be clean with it and go back and do the same thing for the description. So let's do a public string get level description. And let's do an exactly similar thing. Just get the level description and clamp it automatically. This now also means we can actually do serialized field and make it private, just so we don't accidentally get it from this list when we don't want to. Okay, cool. I hope this makes sense. I know we're jumping around a little bit, but there's a lot of things that have to sort of play in at once to this kind of system. Now back into the fireball attack now, finally. Let's keep a private reference to the fireball data.level data. And this will be our level data. So now we're keeping it essentially locally. And then on initialize, let's now store our fireball data as fireball data. because we can cast it to fireball data from the data that the attack class already holds, right? So if we go back into the attack class, you already hold this data, but this is just generic attack data. And essentially in our fireball attack, we're now casting it to our actual level data. But right now we're obviously getting all the data, but we only want a single level data. And the way that we get that is we just do our level data equals 2, and then the fireball data dot get level data of the level that we're currently in, which is also, luckily for us, accessible in the attack. Cool, great. So this is a great base already. Now all we actually have to do is make the attack, well, attack, right? So let's do that. Let's start by first of all saying if the last cast time plus the level data that we have dot cooldown is greater than time, we return. This is essentially just an easy way to make a timer. You could also make a timer that counts up. It wouldn't be wrong. This is just how I prefer doing it. I find it cleaner. So we can just do last cast time equals to time. There we go. So I find this setup clean. You can make a timer however you want again. And this is essentially going to shoot, and then it's going to set the cast time again, and then shoot, and then set the cast time again. And then here, essentially just where we want to do our shooting, right? So here we spawn a projectile. But first we need a projectile. So let's go and get that. So going back out here, I guess we could just put the projectiles under the attacks as well. I mean, the attacks folder might get a little cluttered, but again, you can organize it how you want. So I'm just going to go make what I call a simple projectile. Essentially just going to move linearly. It's going to apply some damage. It's going to be a very simple little thing. Okay, so first of all, I want this moving by rigid body as well. The reason for that is because rigid bodies can easily do trigger collisions, which is what I want to use. So I'm going to do type of rigid body here. All right, cool. And now let's keep every piece of data that we want to keep for this projectile, everything that's relevant. So let's do, for example, private int damage, or sorry, underscore damage. Let's do private float underscore speed. Let's do private float underscore duration, because we might only want it to last for a certain amount of duration. And let's do a private rigid body underscore rigid body. Yeah, cool. And we can also just keep track of a private float that is going to be the lifetime. This is essentially going to be a normal type of timer. Again, you can time things however you want. First of all, let's once again in awake do a try get component for the rigid body. Cool. So now we have the rigid body, and we know it should always be there because we're requiring type of component. And let's also just do in on spawned just for good measure. Oh, sorry. This of course needs to be a network behavior, so it can be spawned. Or network identity, and they are completely the same. And then in unspawned, we just want to do enabled equal to its owner. Right, and now let's make some way of initializing it. So private void initialize, and let's feed the information that we need here. So let's do some damage, let's do some speed, and let's do a lifetime of the bullet, right, or a duration or whatever you want to call it. So let's just default that to something like 4. And let's go in. So now we can store the damage. Damage is damage. Whoops, it also made too many of these. We also have speed. It's equal to speed. Let's do the duration is equal to the duration. And that should mostly be it. And now we should be able to do the rigid body dot linear velocity, and we can just set that equal to the transform dot forward, because we'll just spawn it in the direction that it has to shoot. And we just set that times the speed. Cool, and that should mostly be it. Now let's also make sure that in update we count down the lifetime. So let's just do lifetime. Oh, sorry, again, if we are the owner. So if it's not the owner, we just return just for good measure. And lifetime plus equals 2 time dot delta time. And then we'll essentially just check if the lifetime is greater than or equal to the duration. Means it shouldn't be here anymore, so we can just do destroy of the game object. And it's as easy as that. And now the last thing that we need to do is, of course, just do something when it actually hits something. So let's do on trigger enter. And let's once again just check that we're not the owner. I think it's just always a good idea to do. Let's also now check if we've hit an enemy, right? So hit enemy and then deal damage. But the thing is, we don't have an enemy yet. But now let's start by just getting the shooting working. So let's just leave this here for now. Now we have a bullet. Going back to our fireball attack, we can now set a prefab to this. So let's do a simple projectile like that, and now we can actually handle the shooting. Now first of all, very first thing that we had was we need a for loop, because in our level data we actually had the amount of projectiles that we wanted to shoot. So we want to for each through those. Then we want to get a random direction. So let's just, whoa, there we go. What's wrong with me? There we go. Just do random dot inside unit sphere, like that. Then we can say direction.y because we don't want it going up and down. And then we can normalize the direction. So now we already have a random direction to shoot in. And all we have to do is essentially just spawn the projectile, make it look in that direction, and initialize it. So let's do that. So var projectile equals to instantiate. We want to instantiate the projectile prefab that we have. We want to just instantiate it at our player's position. And actually, let's instantiate it just a little bit. So let's do vector3.up times 0.5, just so we don't instantiate it in the ground. And then let's also do quaternion.look rotation, and then we'll just feed it the random direction that we got, like that. There we go. So now it should look in a random direction. And now all we have to do is we do projectile.initialize, and we can essentially initialize it with our level data.damage, level data.speed, and we can pretty much just keep the duration to default. You could set a duration up in level data too if you wanted, but this should essentially be fine. So cool, now let's go and try this. Oh, last thing, the fireball data. We of course want a create asset menu in here. And we need a menu name, and this can just be attacks/fireball. Cool, because now we need to actually make the scriptable data. So let me go into my scriptable objects folder that I already have. Let me just make a pre-made folder, pre-made, and just drag and drop that one in there. Cool, so now let's make our new data. So I can go create, I can go attacks, and I can go fireball. And now we can just call this fireball data. And you can of course set it up with any icon you want. Like for example, I'm going to set it up with this knob. The prefab for the attack, we actually need to make that as well. And we can also set up the level. So let's make the first level. We shoot 1 projectile, we deal 10 damage. It has 1.5 seconds cooldown, and it flies with 3 speed, for example. That could be our first upgrade. Second upgrade could then be 2 projectiles. Third upgrade could be 20 damage and lower cooldown or something. It could be whatever you want. You can make it as wild as you'd like. And we can do the same thing for level descriptions, right? So the first one, I guess the first one's likely not going to matter when this is going to be our standard one, but you get the idea. So this is going to be at shooting fireball weapon. The next one could be adds 1 extra projectile per shot. And the last one could be double hit damage plus faster shooting. Something like that. And the attack ID, I can just call this fireball. And the attack name could also just be fireball. In this case, doesn't matter much. Let's quickly make the prefab for it. So let's create, and this is going to be the fireball attack prefab. I'm going to add the fireball attack. And we're also going to make the projectile actually. So let's also add the fireball projectile. And let's add a body to it. So sphere, be its body. I'm going to remove the collider from here. I'm just going to scale this down to 0.3 on all sides. I'm also going to give it, I had a material for this already, which is the test red color. And then here I'm going to add the sphere collider, which is going to be 0.15 to match the fireball. That looks right. I'm going to add the fireball attack to it. Oh, sorry, no, this is a projectile. This is a simple projectile, which you can see it has automatically added a rigid body. I don't want this to have gravity. I don't think I really want this to have rotation either. And I guess I want it to also freeze its Y position. And then we're going to make the sphere collider into a trigger. And I think this should just be it. Let me add this to the top. Cool. So let me go into prefabs, drag and drop the fireball in there. And then on the fireball attack, I can now drag and drop the... So now we have the fireball attack here. Now I can also make this into a prefab. Awesome. And now in the scriptable object here, we can now drag and drop the fireball attack prefab, of course, in here. Great. So now we have that too. All right, cool. So now going into our player, we can now add this as an initial attack data, which is gonna be this one. There goes. Now when I hit play, now we're spawning a fireball here, which I think is because the fireball attack is offset. It is indeed. Let me just put this at 0, 0. Try again. There you go. There we go. Yes, now we spawn a fireball from our player. And you can see now we spawn that shoots around, and it's really that easy to make an attack now. Cool. So now we have that attack, and we can make more attacks in the future, but let's start by just making this work. We can also see the balls actually kind of stutter away, so let's go and fix that really quickly by just the rigid body to interpolate, and now that should look a lot better. And this is already, in my opinion, very fun to play around with. For example, we could go to the scriptable object here, and we could shoot 5 projectiles every time and make them shoot super fast or quite fast, like this, for example. I can see we shoot 5 and 5, and you can see we have another player joining. G5. And actually notice how the balls aren't traveling. That is because I forgot to add the network network transform to it. There we go, network transform. So now that should have fixed itself and we should see them moving as well. So there we go. So now you can see, now you should be able to see each other shoot as well. And look at that. Now we already have 2 players moving around, a smooth camera. We have a quite modular shooting or like weapon setup or attack setup. So you can make many different kinds of attacks. It doesn't just have to be a shooting attack. And if there's any attack you'd like to see a tutorial on, let me know in the description as well. But now moving on, let's continue down this path where we're moving rather quick. And let's start by setting up now an enemy. So let's go and make enemy folder. And let's make some enemy movement first. Or actually, we can make both, I suppose. That's both the enemy movement and the enemy health. And actually, let's maybe just start with the enemy health. That might be even easier. Just so we can actually damage the enemy. And we can make the fireball actually hit them. So first of all, let's start, of course, by making this into network identity. And let's just make a serialized field here for private int underscore max health. Let's just set that to 10. Let's do serialized field, private int, and let's also do an XP for kill. This will come in later, but for now I just like to have it. And then we can also make a serialized field and then make it the per read only. Private int current health. Now, just really quickly, the per read only really doesn't do anything functional for you. All it does is just it locks it in the editor. So if we just go and set up the enemy really quickly, I can show you. So I set up a new empty. I'll call this I guess I'll call it zombie. Just put in 0, 0. And let's add the enemy health here. You can see now this is just a read only attribute. That's really all. You just can't modify it. It's just good to sort of see in the editor. All right, cool. So now let's get into awake. Let's take our current health and set it to our max health, because this is likely when they have spawned. And now let's make a server RPC. And let's just for good measure set this to require ownership false. And let's make a public void that we call deal damage. Essentially here, we're just telling the server that we want to damage this monster, right? So we're going to take the current health. We're going to do minus equal to damage. And then we're going to say if underscore current health is less than or equal to 0, then we want him to die. It's not a nice thing to say, but it's just the reality of it. All right, cool. And then here, essentially we just do destroy game object. And that's really the base of it. We're of course going to expand this later to be able to do more. But for now, this should be enough to actually damage him. So going back to our simple projectile, this is now where we actually handle the damaging. So going in here, let's remove the note. And now we can say if the other does not have, or try and get the component out of the enemy health, then we can just return, meaning we have not hit an enemy. And then if we have hit an enemy, we will essentially deal damage to them and we can just destroy the bullet. And that is with a lower capital. There we go. And that should be it. So now we should actually be able to deal damage to zombies as well. Now let's start by actually setting up these zombies. So let's also just drag and drop the movement in here. And let me also set up the body on him. So again, I have the Kenny assets and that was a character zombie that I'm going to use. So there we go. There he is. Handsome as ever. And we're going to make a capsule collider on him. And I'm of course going to zero the pivot here on him. And once again, we're going to make them the same size to the player because they are about the same size. And there we go. So now we have our zombie. And then, yeah, we can also just give him a rigid body just for good measure because we likely want him to move around with a rigid body too. If you don't have to. Again, actually, let's not do that. Let's just keep him here for now. And let's have the player spawn in. And I'm stuck inside him. Hold on. Kind of move him over here. Have the player spawn in. And let's see if we can get lucky and get a hit on him. There we go. If we hit him, you can see the bullet disappeared and the zombie disappeared, which is because the bullet damages 10 and the zombie has 10 HP. Cool. So now that works and we very quickly had some zombie health. Now let's try and get them also moving around. We should be able to do this rather quickly. Now let's set it up as a network behavior again. Like so. And here, let's just identify some kind of speed that we want to give him. So private float speed, and let's also just set it to, let's set it slightly slower than the player. And let me do an underscore on that, because that's my naming convention here. And right, okay, so let's start by figuring out what do we need in order to identify the player. First of all, let's actually move him with a rigid body. You don't have to. I just like the idea of the player being able to push him. And once again, as we've done before, let's just do require component, type of rigid body. And then now we want to essentially know which player we're targeting. So let's target the player health, or let's call this the target player. And let's also just check with some set interval. So we're going to keep track of when we last checked. Now, first of all, as we've done many times before, let's in awake do try get component out for the rigid body. Now that we have the rigid body, we can also go into the unspawned. And in this case, since it is an enemy, I only want the server to be controlling him. So we can just do enabled equals to his server, meaning if we're not the server, he'll be disabled and we won't be controlling him. Cool. Now in fixed update is where we can now handle the moving of him. We can of course once again say if we're not the server, we return. And we can also say if we do not have a target player, we also want to return. Cool, so this now means we know where to go. And with that knowledge, let's set it up. So let's first of all just cache our target position. So we got our target player dot transform dot position. Let's also now calculate the direction that we need to move in. So first of all, we need to calculate the direction itself. So we'll do target position minus the transform dot position that we're currently at. And let's just normalize this. So now we have a clean direction to move. And let's also just make sure that direction is not up or down. So we'll just set the direction y to 0. And now let's start by just setting the rigid body dot linear velocity to the direction times our speed. So now we should already be moving in that direction. And now let's just do the similar thing to what we did with the player. So let's also set the look rotation to quaternion look rotation of the direction. And now we can actually have the rigid body dot move rotation used here. And we can slurp it so that it'll move slowly into the right rotation. It's likely not going to matter a lot, but I like smoothing rotations in some cases, for example, here for enemies. So essentially what we're going to be moving is we're going to be moving from the current rotation to the look rotation, and we're going to be moving with time.fixed delta time. And we're just going to do it with some level of rotation speed. I'm just going to use some arbitrary 10 times. You can set a rotation speed up if you need it. Cool. And the very last thing now that we need is we need to figure out how do we actually find the target player. And for that, I'd like to once again use the iTick. I just want to calculate it using ticks. So once we've now set this up, let's once again set up that if we are not the server, we just return. And let's also just check, let's say once a second, right? So exactly what it wants to do here, essentially, if the last player check plus 1 second is greater than time, then we don't want to check. So now we can also set the last player check equals to time.time here, because now we're essentially running a check. Cool. First thing that we need is we need a way to get all the players. And so how do we do that? Well, let's hop into... I am sorry, I skipped a step here. We actually don't have the player health yet. So let me just create that. Let's create the player health. So so now I've created the player health. And this player health is also a network behavior, right? And we'll get into making the actual player health a little bit. But essentially what we need, and the most important bit that we need, is we need to get all of the possible player healths. So one easy way to do this is we can just keep a static dictionary of all player health. We can even make this read-only because it's not going to be modified in that sense. Then we can make the dictionary and we can make it of type player ID to player health. And this can just be underscore all players, for example. We set that to a new, and then we can make a public getter for it as well. So we can make a public getter for a dictionary of all players. All right, cool. So now we have a dictionary of all the players. Let's also populate it. So let's do an onspawned. Let's do underscore all players. And actually, let's first do if owner.hasValue, just for good measure. And then we'll just set the owner.value equals to this. And on despawned, we'll of course then remove it again. So we'll do if owner.hasValue, we'll do underscore all players dot remove the owner.value. And when you do work with statics, one good safety measure to always make is to actually use Unity's runtime initialize on load method. And let me just make a private static void that we call clear. And that's essentially going to clear dictionary. Now, what is this? This essentially before runtime ever starts, it'll run this method. or essentially as runtime pretty much starts, it'll run this method, which means this will be in the very, very, very beginning of your game, essentially just ensuring that we have a clean dictionary, because statics can be a little tricky and they don't necessarily clean up well. Even though we are removing them and on despawned, static stuff will just tend to misalign, and we don't want that. So here we have the base of just what we need in our player health now. So going back to our enemy movement, now we actually have all of the stuff that we need. So what we can do is we can get all the players. We can do var all players equals to player health dot all players. Now I have them all here. And let me go in here. It actually annoyed me a little bit. I named this non-capitalized. Don't like that. So let me just do that. All right, cool. So going back in here. Now we have all the players. And now we can essentially first of all, find out if the all players.count for one reason or another is 0, we just return, there's no point in continuing. And now let's try and find the closest player. So player ID will be the ID of the closest player, and we'll just start by setting this to default because we haven't found the closest player yet. And we'll also want to track the closest distance, which will just be float.max value, essentially as much distance as can be. Right, so now let's for each through each of our players. So all players, player. And we can actually, so this should be fine. And what we can do is we can get the player position, we can cache it. So our player position equals to player.value.transform.position. We can also now calculate the distance. We can do vector3.distance between the player position and the transform.position. And now we can determine if this distance is less than the closest distance that we've already calculated. Then we essentially want to say that this is the new closest player. Equals to player.key, and the closest distance equals to the distance that we calculated, like so. And essentially now we can just, down here at the bottom, we can say if closest player is still equal to default, well then what we just done doesn't matter, and if it's not, we can do the player health.players.try get value to the closest player that we got out, and then we can out the target player. So essentially what we're doing now, whoops, not out, there we go. So essentially what we're doing now is we're just finding out which player ID is closest, and then we're setting that ID back to being our actual target. And so this shouldn't work now. This should essentially mean that now we have a target. So let's try and go and test this out. So now we have the player movement, it should work. And if we start, whoops, what happened there? Just fell through the ground. If I increase, there we go. Let's see if he starts moving. Oh, of course, I forgot to add the player health to the player. So let me add player health here, like so. Put it up here somewhere. Whoops. Cool, there goes. Now let's try and play. And now he should, there we go. Now he starts moving after us. He is moving a little bit weird, so I guess we'll try and figure out why that is. But yeah, essentially he's now moving after us. And if I try and have the other client join, I feel like, oh, actually, did I just forget on his rigid body? I did, to just lock all of these. There we go. There it goes. Now it's moving more normal. That looks good. Okay, cool. And now just for testing, because I find this very satisfying to do, let's add a bunch of zombies. So now we have a whole bunch of zombies. I'm going to do that. I'm going to join with my client here. And notice how the ones that are closer to the client will go for him instead. So there you go. Now you can see now they're closer to the client, so they'll aim for the client instead, because he's now the new closest player, and that's calculated every 1 second. All right, cool. So now we have the zombie movement also working. So let's actually make a prefab out of our zombie. I'm just going to drag and drop it out here. Cool. And I guess the next thing that's also good to have is that our players can actually take some damage. So we already set up the player health that you saw. Now let's continue actually setting that up a little bit. So first things first, let's make a serialized field. Let's make that a private sync var for an integer, and let's call this our max health. And let's default that, let's default that to 100 and make it owner auth to true, so that it's us that decides whether we take damage or not. And let's also make a new one that we call current health. That is also owner auth true. This is just because, we could potentially modify our max health or something later on. And let's also just make some very handy getters. I don't know if we will actually need these in the future, but I always just like having them. We have max health.value, and we can also potentially do public int current health and to point to the current health value. All right, so now that we have these, let's, for example, also subscribe to when our current health changes. So let's go into awake and do on current health dot on changed plus equal to on health changed. And let's also make sure to unsubscribe from it again. So let's go into on destroy here. And let's make sure to unsubscribe again properly from that. And let's make the on health change method. And this will be our new health that's coming out here. Cool. And essentially what we want to do here is we just want to check if new health is less than _0 and we are the owner. This is where we'd essentially want to die as well. So we can make the die method. There it goes. Now players can also die. You could also just despawn them, do whatever you want here. Later on, we're gonna, change the state and so on in here. Right now we can, I guess, just call debug.log you are dead. Okay, cool. So with that now, let's also just give the ability to change the health and set the health. So let's do a, let's go down here and let me actually move these down. I like having this stuff at the top. Let's move these down and let's now make a public void change health, which is going to be int of the, not health, of the change. And we essentially want to do if we're not the owner, which is return, because we only want to be able to change our own health, because it's an owner or sync var. And essentially we just want to do, essentially just clamp the value and set it to the clamp between the change. Cool, yeah, so that works well. This could also be where you just check if you're dead. Honestly, that would be fine too. Both works. And let's also just for good measure make a public void set health. And just whatever health we can set it to. This could be if you want to, I guess if you want to do a heal, you just change it here. But let's say you want to set us back to max health or set us to 0 because we have to instant die or something. You can easily do that here. So let's just do current health equals to health. Cool. And let's just once again do it for another owner, we return. Okay, so now we have the ability to actually damage ourselves here as well. So now let's set up the enemies so that they can damage us. Now in the enemy script here as well, let's just make an enemy attack _ melee, for example, because this is just going to be when they touch. I'm going to, of course, make this into a network behavior. Actually, I don't think we need this to be a network behavior, to be honest. Let's do a serialized field, private int damage. And let's just say that they deal 10 damage. And let's make an on collision stay. And let's also have a private float for when it lasted damage. So last attack time, I guess we can call it. Yeah, that's fine. Okay, cool. So first of all, let's just check if last attack time plus, let's just do 1 second right now. Again, this is whatever attack cooldown you want the enemy to have. I am just going to hard code it because I am lazy. And actually, if this is greater than time to time, we just want to return. And then let's do if other dot try get dot transform dot try get component out player health, which will be the player health. And actually, if we do not get a player health, we will return. And we can also just say or player health dot is owner. And so if we are not the owner, remember this little symbol here, which means we are now the owner of it, which means we can set the last attack time. I can also do player health dot change health minus the damage that we want to deal. There we go. We should be able to just put this on an enemy now, and I'm pretty sure that should just work. Doesn't even have to be networked. There's no network logic really going on here other than the ownership check. So let me go into my zombie. Let me add the melee here. And let's just, for the sake of testing, just give him 10,000 health. And cool. Yeah, so now he should deal 10 damage. Let's just test that out. Let's go into our player here. We should be able to see on our player health. We should be able to see our current health value. You can see now 60, 50, 40, 30, 20, 10, and there we go. And now it should say you are dead, and you can see it doesn't go below 0 because it's clamped. All right, cool. So now that actually works. And I think also if we go onto the zombie here, we should be able to see he's on 9800, 97. Okay, yeah, so this works pretty well as well. Cool, let's set him back to 10 health, so he only gets 1 tapped. Okay, cool. So now zombies can attack. We can take damage. They can take damage. They can die. Let's set up some level of, I guess, zombie spawning as well. Might be a good next step to have. So let me set up a game manager object. Let's also just save this zombie to the prefab. So now it has the attack as well. We're going to remove this zombie. So now let's go back into our scripts folder. And I guess I'll make a managers folder as well. And in this managers folder, I'm just going to go create new. And this is just going to be an enemy spawner. Now for the spawner, I'm just going to go very lazy. Because making a spawner is a very simple thing. So I'm just going to make the very base of it. Like I'm going to set up some pre-set up list of spawn points. So something like just that, and let's just set up some like serialized field, private, float, spawn interval equals to, I don't know, let's say 3, 2, I don't know, doesn't matter. And let's also just keep a list of all the enemies. So let's just do serialized field, private list of enemy health, and this will be the enemies. Cool, so now we have that. Now let's once again make this into a network behavior because we want to only have the server control this. So let's do unspawned, whoops, unspawned like so. We'll just do enabled equals to is server. And now let's in the update loop, just do if it's not the server as well. Again, just for safety's sake. Let's do something like that. And let's also, I guess, have a sort of a max enemy counter of some kind. Let's just do private int max enemies. Let's set that to something like 20, not floats, just 20. Cool. And that also means we now need to be able to keep track of the enemies that we have spawned. So let me make a private list of enemy health. This will be spawned enemies equals to new, something like this. And so we can say if spawned enemies dot count is greater than or equal to the max enemies, we just return. We can also say, let's keep track of our last time that we spawned. So private float last spawn time. And we can do if, whoops, if last spawn time plus the spawn interval is greater than time.time. We just want to return. And I guess another fun thing we could actually do right now is we could make a different spawn interval. So we could make a private float actual spawn interval. And we can make a pointer to the spawn interval divided by the amount of players that we have in the game. So we could do like network manager dot players dot count, for example. So the more players we have, the smaller the spawn interval will be. I think that's kind of nice little addition. And I think that just don't know what the underscore. Okay, cool. And so essentially now here's where we got to spawn the enemy. So we can do last spawn time, and then we can do spawn enemy. Let me make a private void spawn enemy, like so. And I guess first of all, let's just check if the enemies list is less than or equal to 0, or there's no spawn points. There's no enemies or spawn points available. That's a fine log. And now let's do the actual spawning. So let's do a var enemy equals to instantiate, and we'll do of enemies in just random dot range from 0 to enemies dot count, and we'll spawn them at a random spawn point. So let's do var spawn position equals to spawn points, similar thing, random dot range from 0 to spawn points dot count, and let's just do dot position. So that we have the spawn position. They will just spawn in quaternion.identity, and that should be fine. Cool. So now we have our new enemy, which I've spelled correctly, by the way. Now we have our new enemy, and let's just do, so he's already spawned, then let's add him to the list. So spawned enemies. Add enemy. Cool. So now we have that enemy. And I think now we should also be able to know when an enemy dies, which should be pretty easy, luckily. Because what we can just do is we can make a public static action that is going to hold the enemy health, and this is going to be on enemy killed. And that can just be called down here in the die, so we can just invoke that with this enemy. Which now means in the enemy spawner, we can just do if is server, we'll just subscribe to the enemy health dot enemy killed was equal to on enemy killed, like that. And now we can also just on despawn, so unsubscribe from it. So like that, we'll just unsubscribe from the on enemy killed. like so. And this will be the enemy. And we can just check. Essentially, we just do spawned enemies dot remove the enemy. And cool, so that should be it. So now we should essentially also remove him from the list so we can correctly track how many enemies there are. I guess an easy way to test that this works as intended is adding the enemy spawner on here. So let me add the enemy spawner. Let's add these spawn points. So let me make those into like a red thing. Let's just position them all around the place. Let's do one there, one there, one there, one there, one there. Yeah, just all over the place. We just put them around. Again, I would say calculate this dynamically in your own setup. I am just taking a lazy approach here because I just need to get it working, and this is not a tutorial on making spawning work. And let's drag and drop in the zombie that we now have. There we go. Now the enemy health. Now let's just set the spawn interval to something like 0.1, something super low. We should be able to see zombies spawn really, really quick. And at some point we should see it stop. Like no more zombies show up essentially, which it does. Right now we're obviously killing them again, which means they spawn again. But as you can see, we're not completely swamped by enemies, whereas if we took this max enemies number way up, which we can, well, just have a look at the amount of enemies here. And now if I took this way up, you should see now we should get many, many more enemies. Cool, so this seems to be working really well. Wow, that is a lot of enemies. But yeah, this seems to be working pretty well. So that's cool. We now know that works. And that concludes the end of the first video. Now in the second video, we're going to finish it off, get all the leveling stuff set up, and pretty much everything else that's missing. So please stay around to that one. I hope you watch it. The link will be in the top comment in the description as well, and it should also show up on the ending screen here. Other than this, I just hope that you have a wonderful day, and thank you so much for watching. Please do leave a like, comment, and subscribe, and I'll see you in the next one.